Hi students, I want to explain how to process the data you are going to obtain during the lab of collision. So basically, in this lab, you have five different balls, so five balls that are just made of different materials, glass, steel, ceramic, I don't know. So five different balls. And now we are going to be dropping, each of these balls from approximately 1 meter. This height of 1 meter is what we call H, right? Now, the ball is gonna rebound against this hard surface, and then, of course, it's not going to reach the same height we have initially. So we are gonna call the new height, H prime, right? So there will be a delta H there. That is a difference between the height uh, initial, there was 1 meter approximately. You must measure it, right? And the height that the ball reached after the collision with the hard surface. Now, we must measure, these different values of H prime. Of course, you are going to repeat this experiment approximately 7 times for each ball, right? So suppose I am working with a glass ball, I will just drop the glass ball from 1 meter and 7 times, and I will measure, how high go the ball, after colliding with the hard surface. I will be recording this in this table over here. So I have my 7 trials and I have my 7 values of H prime. Once I have the 7 values of H prime, I will find in this case H prime mean, so the mean of H prime. How do you find the mean of H prime? You will add these 7 values and you will divide by 7. And that is going to give you the mean, of the height that the ball reached, after rebounding. Remember that I am doing this for one of the balls, for the glass ball. You must do it for 5 different balls, for 5 different materials. Now, once you know H prime, you must find the standard deviation. So you know the mean. Now you will find the standard deviation. How do you find the standard deviation? You have your 7 values of H prime here, so value from 1 to 7. You will subtract here to find the deviation, each of these values minus the mean of H prime, and then you will find the square of the deviations, right? So you will find the square of the deviations. That would be the square of H prime minus H mean, right? The square of that. So you find the total of the third column, and with this total of the third column, you go and you just plug in that value here in the expression to find the standard deviation for H prime. So the standard deviation for H prime would be 1 over n minus 1 if n in this case is 7 because we are doing 7 trials. This is 1 over 7 minus 1 times the sum from I equals 1 to n of h sub I prime minus h prime mean square, right? The square root of that. So this is your standard deviation, for the sample we took for h prime. Now, how do you find the relative error? To find the relative error, you're going to divide the standard deviation, right, that you found by the mean. Okay, so like that you will find the relative error. Now, how do you calculate the coefficient of elasticity? The coefficient of elasticity would be in this case, square root of the quotient of the mean of h prime over h. So for each ball, you found an h prime. For each type of ball, glass ball, steel ball, ceramic ball, right? So for each of these balls, you found an h prime mean, right? If you divide that h prime mean by h, that was the initial height, and you find the square root of that, you find the coefficient of elasticity, right? Now, once you have the coefficient of elasticity, you can find the fraction of kinetic energy that was lost in the collision. That would be 1 minus the square of E, 1 minus the square of the coefficient of elasticity, right? If you multiply this by 100, instead of having this as a decimal value, you will have this in percentage. So you will have the percent of of kinetic energy that was lost in the collision between the ball you were dropping and the hard surface, right? So you will find what is the percentage of kinetic energy that we lost. So this is basically what the lab number 40 is, right? So this is what you have to do. Just read the instructions for the rest of the actions, or steps you must follow as part of this lab. But this is just the base of, what this lab is about, right? So I hope that with this video, you will be able to understand, how to perform this lab number 4 about collision, and you're going to obtain the correct result. So thank you for your attention.